Hello and welcome to the CompTIA Cybersecurity Analyst, CySA Plus, Certification Study Guide. In this video, we will discuss Chapter 3.4 Networking. Please like, subscribe, and hit the notification bell. Zero Trust. The final cybersecurity foundation category is networking. Topics in this category include zero trust architecture and secure access service edge. A relatively new defense applied to networks has been growing in popularity. This is known as zero trust. It is important to understand what it is, its principles, and how it is applied through a zero trust architecture. 20 years ago, most networks were based on a traditional security model that operated on the assumption that everything inside an organization's network can be trusted. Because all users within the network are trusted users, all users in the network will act responsibly. However, as threat actors became increasingly adept at infiltrating networks, it was soon realized that this traditional network security model was no longer viable. In other words, relying exclusively on prevention was no longer a winning strategy. 10 years ago, the focus again shifted. The goal this time was to rapidly detect any intruders who might break into the network. This would allow for a rapid response for action to be taken. But just as the original network security model proved defective, so too was this revised model. By the time it was discovered that threat actors had infiltrated the network, these skilled attackers had moved into other parts of the network. Valuable time was wasted trying to understand the intention of the threat actor and what resources they were targeting. Both flawed network security models resulted in Security Operations Center, SOC, cybersecurity professionals, focusing exclusively on stopping and blocking the attackers. This is because both flawed models relied on the same assumption: threat actors are trying to enter the network. However, this assumption is false. Attackers were already inside the network. Modern threat actors are not trying to enter the network from the outside, but are currently on the inside. Many users are shocked that attackers are already lurking inside a secure network. However, that has become the reality today. The network perimeter by itself does not keep attackers out, and it is not possible to detect and block a threat actor quickly enough when an attack is discovered. Instead, controls must be employed on a new assumption: every network is infiltrated and thus untrusted. There is a control designed to address this assumption that the network is already infected. Zero Trust is a strategic initiative about networks that is designed to stymie successful attacks by threat actors who are already within a network. As its name implies, Zero Trust attempts to eliminate the concept of trust from an organization's network architecture. Zero Trust acknowledges that implicit trust, trusting everyone within a network, is a vulnerability. This is because networks have been designed so that once inside the network, users can freely move to access or exfiltrate data. Yet because most networks have already been compromised, malicious attackers likewise can freely move through the network. Zero Trust is not designed to make a system trusted. Instead, Zero Trust works to eliminate trust. The motto of Zero Trust is never trust, always verify. There are several principles of Zero Trust. Revise network security goals. While at one time the goal of network security was to prevent all network breaches or respond quickly enough to fix them, these are not the goals of Zero Trust. Instead, by assuming a breach has already occurred, the goal is limiting and containing. Eliminate implicit trust. Prior security models assumed that any subject inside the network was there because they had been authenticated and approved, and thus they could access virtually any resource. Zero Trust requires that every interaction between users, workloads, network resources, data, and devices must first be verified before it is allowed to occur. Enforce granular least privilege. While least privilege has often been used when referring to limiting a user's permissions to only those resources that are required, what about applications, devices, and integrated systems? These entities also must have least privilege enforced so that they can only access a resource to perform an authorized task, and no more than that. Utilize allow lists. An allow list is a model designed to block all traffic that is not specifically permitted. In the Zero Trust model, nothing is implicitly trusted, and everything must be first verified through an allow list. Move the line of trust. At one time, the dividing line between trusted and untrusted was the gateway into the internet. Anything on the corporate network side of the gateway was trusted while everything on the internet was untrusted. Zero Trust recognizes that because a threat actor has already infiltrated the network, then the network can no longer be trusted. Thus, the line between trusted and untrusted must be moved. Prevent east-west lateral movement. Once a threat actor infiltrates a network, they rarely, if ever, remain where the breach occurs. Instead, they quickly perform reconnaissance to become familiar with network hierarchies, host naming conventions, and the locations of assets, gather privileges like login credentials, and then move laterally, called east-west, to the valuable and desired resources. Zero Trust helps prevent this movement. Another principle of Zero Trust is to segment the network into much smaller pieces called microsegmentations. This helps prevent lateral movement across data networks, campus networks, and even the cloud. Network segmentation, using Internet Protocol subnets, Layer 3, or virtual local area networks, VLANs, Layer 2, for microsegmentation leverages existing technologies. Management of these segments can be difficult or require the network to be re-architected. Firewall segmentation firewalls, common around the perimeter of the network, can be deployed inside a network for microsegmentation. Using firewalls can be expensive due to the number of devices needed. Many require hundreds or thousands of firewall rules, and misconfigurations can break applications. Software-defined networking, SDN policies can funnel packets through a distributed set of virtual software firewalls. This adds a layer of complexity and may be difficult to segment applications that do not fit within set network boundaries. Host-based segmentation uses workload telemetry to create a map of computer environments and applications that can then be used to determine what needs to be protected. This is considered the best approach for Zero Trust due to its reliance on the host instead of other external devices. A Zero Trust architecture, ZTA, is a framework for implementing Zero Trust in an enterprise. Zero Trust focuses on authentication and authorization to shrink implicit trust while still maintaining availability. The goal of ZTA is to prevent unauthorized access to data and services by making access control enforcement as precise and granular as possible, policy-driven access control. When properly implemented, ZTA minimizes threats against assets, threat scope reduction. A user, subject, or another device, system, requests access to a resource. The user is considered to be in an untrusted zone while the resource is in a secured zone that cannot be accessed without approval. Users are verified through adaptive identity, which takes into consideration more than just a username and password. It can also include the role of the user in the organization, their location, the resources being requested, and any prior behavior on the network that deviates from a baseline. The policy engine is a component of the policy decision point, PDP, that provides input into the policy enforcement point, PEP, to make the decision whether to grant access for a request. The policy engine relies on policy automation that uses automated processes for referring to policies for approval. The control plane is used for communication while the data plane is used for the transfer of the resource if approved. A conceptual ZTA is illustrated in Figure 3.7. In early 2022, an executive order from the President of the United States mandated that all government agencies must achieve specific Zero Trust security goals by the end of fiscal year 2024. A change has taken place regarding where employees accessed IT resources for their jobs. Many employees now enjoy hybrid work, with time split between the office and working from home. It has been said that today, work is viewed as an activity instead of a place. Hybrid work has required organizations to make their IT resources accessible from virtually any location. This accelerated the shift to using the cloud for storing and processing data. Almost overnight, cloud models such as software as a service, SaaS, platform as a service, PaaS, and infrastructure as a service, IaaS, became part of the everyday IT vocabulary. Instead of being confined to an on-prem data center, data was now moving from the local data center up to cloud services, which includes both public and hybrid clouds, and then moved back down to branch offices before returning back to the data center. As increasing numbers of users as well as IT resources were remote, this resulted in organizations struggling to provide sufficient levels of connectivity while ensuring strong cybersecurity defenses. However, most network and cybersecurity products on the market at that time were not designed to handle all the types of traffic and security threats that organizations suddenly faced. In order to handle these different requirements, organizations had to quickly adopt multiple appliances and products such as secure web gateways, SWGs, firewalls, virtual private network, VPN, remote access, multi-protocol label switching, MPLS, and software-defined wide area networks, SD-WANs. And for each of these appliances and products, architectures had to be deployed, policies had to be configured, interfaces had to be managed, and resulting logs had to be reviewed. This created a significant burden on SOCs in terms of costs and complexity. These also contributed to gaps in cybersecurity defenses. Clearly, a different solution was called for. What was needed was something that could help organizations embrace cloud, hybrid, and remote connectivity by providing network architecture and network cybersecurity services. And this needed to be accessed from a common cloud-delivered architecture. The solution is a Secure Access Service Edge, SASE, pronounced SASE. SASE is the convergence of several security services into a single cloud-delivered service model. It has been defined as security functions delivered as a service that are based on the identity of the user or system and its real-time usage context. This allows for predefined enterprise security policies to be applied while continuously assessing security risks throughout the session. In other words, a CySA architecture identifies users and devices, applies policy-based security, and then delivers secure access to the appropriate application or data. There are various technologies that combine to make up a SASE. These include KSB, ZTA, secure web gateways, SWGs, and wide area networking, WAN technologies. WANs are a form of telecommunication networks that can connect devices from multiple remote locations and are established by telecommunication service providers that lease the network to businesses. A subset of SASE that only includes the security components and not the WAN is called a Security Services Edge, SSE. A SASE is illustrated in Figure 3.8. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. We will see you on the next one.